Hello and welcome to this Edexcel Further Math Statistics 1 video looking at an introduction to probability generating functions. Now, starting with a simple example, just a spinner that is equally likely to land on 0, 1, 2 or 3, we can summarize the probability distribution by this table here because the probability of each outcome would be a quarter. And what we're going to look at is the expected value of x for this particular distribution and also the expected value of a function of x. And you should recall studying this earlier on in the videos looking at discrete random variables. So our expected value of x is simply x multiplied by the probability that we obtain that particular outcome. So very simply it equals this, and if we sum that it comes to 6 over 4 or 3 over 2. So the expected value for x, the outcome on this spinner, is 6 over 4 or 3 over 2. If we look at a function of x rather than x, we simply sum the function of x multiplied by the probability x takes the particular value involved. And so, for example, looking at the expected value of x squared, when x is 0, x squared is 0, so it'd be 0 multiplied by a quarter. 1 squared is 1, so 1 multiplied by a quarter. 2 squared is 4, so 4 multiplied by a quarter, and 3 squared, 9, so 9 multiplied by a quarter for ex squared, and that gives us 14 over 4 or 7 over 2 for ex squared. And what we're going to consider is the general rule for the expectation of a function of x, and look at the expectation of the function t to the power x, where t is a dummy variable, so not involved in the distribution. We have introduced it in order to get a function in terms of t, and you will start to explore what that function is and how it works later on in this video. And so if we just go from the definition of the expected value of t to the power x, for our spinner we would have the first outcome of x is 0, so t to the power 0 multiplied by a quarter, t to the power 1 multiplied by a quarter, t squared multiplied by a quarter, and t cubed multiplied by a quarter. So clearly a polynomial in terms of t, where the coefficients of t are the probabilities that x takes the value that the power is for t on each particular occasion. And this particular type of polynomial in terms of a dummy variable t, e to the tx, is called a probability generating function and is written gx of t. So it's referring to the distribution x, and it is in terms of a dummy variable t. So for our spinner, if we do t to the 0 multiplied by the probability of 0, t to the 1 multiplied by the probability of 1, t squared multiplied by the probability of 2, t cubed multiplied by the probability of getting 3, this would give us a function in terms of t as 1 plus t squared plus t cubed divided by 4, or a quarter multiplied by that. And you can see how useful the generating function is here, giving us the coefficient t to the power 0 as the probability of getting 0, t to the power 1 the probability of getting 1, etc. So we have all the information in our probability generating function about the particular outcomes possible for x that appear as the powers of t, and the coefficients of those powers give us the probability in each case. So to summarise, our probability generating function gx of t is obtained from this expression here, the expected value of t to the x. It is written out term by term as a polynomial in t, as this line here, where t is this dummy variable that facilitates us being able to have a useful way of expressing the outcomes and the individual probabilities of those outcomes for a discrete random variable, provided that discrete random variable just takes integer values. And we will explore this more in the series of videos. So let's consider now what happens if our dummy variable t equals 1. What does g of 1 represent? And going from the definition of a generating function given here, if t is allowed to equal 1, then clearly t to the power x is always equal to 1, and therefore we are simply going to get for g of 1 the sum of the probabilities of all the possible outcomes for x, and clearly the sum of the probabilities over the whole range of outcomes for x will always equal 1. And this result is true for all probability generating functions. If we have a look at an example here, we are given a generating function, and from that we should be able to obtain all the information about the distribution of x, the values that x can take and the probability that it takes those values. What we need to do is to just write our generating function in terms of powers of x. So we have 2/5 t, or t to the 1, and we have 3/5 t cubed, simply multiplying out the generating function. And that gives us some very interesting information. So we know that the outcomes of x are going between 1 and 3, but it's a discrete random variable. We could have 0, 1, 2, 3, and we obviously could have a value bigger than 3. But if we look at our generating function, the coefficient of t to the 0, well, there is none, so it's 0. The coefficient of t to the power 1 is 2/5, and that's the probability x equals 1. The coefficient of t squared, again, there is no term in t squared, so the coefficient is 0. The coefficient of 3, t cubed, is 3/5, so the probability x equals 3 is 3/5, and there are no other terms. And so just by considering the generating function, we can write down the exact nature of the distribution of x. And here it is summarized for you. Example 2 is looking at a uniform distribution, so we have 8 possible outcomes. It's uniform, so the probability of any one outcome is the same as any one other outcome. So the probability that x takes any one of those values is going to be 1/8. And if we look at the generating function for this distribution, we can take the value x equals 0. So the first term in our generating function is t to the 0 multiplied by the probability of 0, t to the 1 multiplied by the probability of getting 1, etc., until we have the last outcome, x is 7, t to the 7 multiplied by the probability that x takes the value 7. And so we've summarized here the values x can take, and we've obtained, and we can factorize the 1/8 out to make it look a bit simple, the generating function in terms of powers of t, and obviously we can write t to the 0 just as 1 there. So t to the 4, t to the 5, t to the 6, t to the 7. So for example 3, this is slightly different. We have a generating function for a random variable y that has an unknown constant k in it. And the first thing we're required to do is find the value of k. And in order to do that, we need to recall the fact that the generating function with t equals 1 always equals 1. And if we work out the generating function here where t equals 1, we would get 1 over k, and then 3 plus 1 plus 1 squared. Squared must equal 1, so 25 over k equals 1. That implies k equals 25. And to do part B, what we need to think about is the fact that the coefficient of t cubed will give us the probability that y equals 3. And in order to find the coefficient of t cubed, we are going to have to take our generating function that we now know to be this, and we are going to have to expand the brackets. We're going to have to square 3 plus t squared so that we can obtain each term in each power of t. And you probably want to try this for yourself. This is the expansion of 3 plus t squared squared, and if we put powers of t together, collect common terms, then I think we can identify that the coefficient of t cubed is 2 over 25, and therefore the probability that y equals 3 is 2 over 25. And that concludes this video. The next video will look at generating functions for linear transformations of a variable.